Hey everyone, I wanted to show you a couple of examples on how to calculate the number of protons, neutrons, and electrons, since I kind of went through that a little bit fast last class. So first of all, let's do this first example where we have 15 nitrogen, or nitrogen 15, I guess you would really call it. And here we notice that 15 is the mass number, and then we have a number written right below it, this 7 right here, and if you remember, that is the atomic number. And so for this example, we have the mass number, we have the atomic number, and we see up here that there's no charge written. And since there's no charge written, we know that electron number equals the number of protons. And then also, we have all the numbers here that we need. So if I start looking at it, so I see that the atomic number equals 7. So atomic number equals 7. But we remember that atomic number equals the number of protons. So I'm going to say proton number. So we could say that the proton number, I'm going to abbreviate it as P, equals 7. And we don't even have to look at our periodic table to figure that out because we have that extra information here. But then we can also see that the protons plus neutrons, P plus N equals 15. So you could either do this where you're going to do it that mathematical way, where you say, well, protons plus neutrons equals 15. So then, and we can fill in protons equals 7, so 7 plus N equals 15. Then we could say 15 minus, N equals 15 minus 7. And then lastly, we would get N equals 8. Or, like I said, you can just kind of count up from 7 until you get to 15 and see how many numbers that is. So take your fingers and start with 7 and start counting and hold a 1 with your finger. So 7, 8, 9, 10, 11, 12, 13, 14, 15. And you're going to have 8 fingers up, and that's because there's 8 neutrons. So we have proton number equals 7, neutron number equals 8. And then if you remember this information right here, since there's no charge given, that told us something really important, and that's that the electron number, and we usually abbreviate that as E with a negative sign just because electrons are negatively charged. And we could say E minus, so electron number equals, it's the same as the proton number. And we know that it's the same as the proton number because there is no charge, and the only way that there can be no charge is if the number of positive charges from protons equals the number of negative charges from the electrons. So 7 protons, 7 electrons, and 8 neutrons. All right, next, let's do this example with potassium 40. Here, I'm giving you a little bit less information. We have the mass number here, 40, but we are not given the atomic number. But if you remember, we can find that somewhere. So let's take a second and go to our periodic table, and we can see that we have, we're going to zoom in on potassium here. We said we have potassium 40. But potassium, every single potassium in existence has 19 protons. So we're going to take that information and fill that in here. So we can just write that since the atomic number equals 19, the proton number equals 19. And next, we can start calculating the number of neutrons. So we said protons plus neutrons equals 40. And then since protons equals 19, we can, I'm just going to calculate it the mathematical way, or you can probably, some of you can probably do this in your head, but 19 plus N equals 40. And you could say 40, or N equals 40 minus 19, so N equals 21. All right, so we have proton number, we have neutron number, and then lastly, we're looking for the electron number. And can anybody guess what electron number is? If you remember what I just said in that previous problem, the electron number, we're going to see that there are no charges here. Since there's no charge written, we know that the electron number is going to be the same as the proton number. So electron number equals 19. All right, let's scroll down to a little bit harder examples. When we have a charge, we have an extra step because electron number only equals the proton number when there is no charge. So if there is a charge, then we got to do things a little bit differently. So we're going to go back and we see again that we have the mass number given. That's going to tell us protons plus neutrons. But here, just like the previous example, we don't have anything written down for the atomic number. So we need to look up sulfur, which is S, on the periodic table and find what the atomic number or the number of protons is. So let's just look up sulfur on the periodic table. We see it right here. Sulfur has 16 protons. It always has 16 protons. Every single time, every single sulfur in the entire universe always has 16 protons. So the protons equals 16. And then the number of protons plus neutrons equals 33. So we're just going to plug it in. So 16 plus n equals 33, and then n equals 33 minus 16, n equals 17. So we have proton number, we have neutron number. Notice that we did nothing, absolutely nothing different to calculate both of either of these. The only difference when there is a charge is calculating the number of electrons. So something else that I wrote that I told you guys about last time is when I have the number of protons, I might as well write that in pen because that number does not change. Do not change this number after you calculate it. After you look it up on the periodic table, don't change this number. And I pointed that out because a lot of people try to do that when they try to do stuff with this charge. So we have the number of electrons is not going to equal the number of protons. We see from this charge that there are this negative charge here. Since we notice that this charge is negative, I'm just going crazy with these colors right now, but we see that this charge is negative. That's really important information. So that tells us that the number of negative charges is greater than the number of positive charges. There are more negative charges than there are positive charges, and that's why we have an overall negative charge. So if the number of protons is 16, and there's more negative charges than positive charges, remember protons are positive, then we know that the number of electrons is greater than 16. So we just established that there are more negative charges than positive charges, so we know that there are more electrons than protons. All right, one step further, how many more electrons than protons? Well, let's look at what the charge is. So we said it's negative, but let's see what number we have here. There's a 2 there. That tells us that there's specifically 2 more negative charges than positive charges. And if there are, if there are 16 protons and there are 2 more negative charges than positive charges, that means there are 2 more electrons than protons, and therefore the number of electrons is just 2 more than 16, so it is 18. And then that's how we calculate it every time there's a negatively charged ion. Lastly, if we have a positively charged ion, let's see what we do here. It's going to be a lot of the same. So we have the mass number, and we are not given the atomic number. So we're going to have to look that up. Atomic number is not given. So we're going to have to find aluminum on the periodic table, and let's do that. So aluminum has an atomic number of 13, meaning it has 13 protons. So we can write down that the number of protons equals 13. Yep, so 13 protons. And so that should be the first easy step. If the atomic number is not written, you're just going to look it up on the periodic table and just write down that number. That's the number of protons. Boom, you already got 1 out of 3 points. Next, we are going to see that protons plus neutrons equals 28 because the mass number is 28. So then I can plug things in. So I see that there's 13 protons plus n equals 28. 28 minus n equals 28 minus 13. And so we get n equals 15. So we have proton number. We have neutron number. Again, when there's a charge, there is no difference on how you determine the number of protons and neutrons. We are going to pretend that I wrote this in pen because this number is not going to change, this number of protons. The neutron number is not going to change either, if you want to go over that in Sharpie or something. The neutron number does not change either. We are specifically now calculating the number of electrons, and these numbers, the protons and neutron number, are not affected by the number of electrons at all. So now we're going to look at the charge. We see that there's a +3 charge. So +3 charge, specifically, let's forget about the 3. We see that there's a positive charge. So a positive charge means there's more protons, or there's more positive charges than negative charges. And that translates to there are more protons than electrons. So that means that since we know that the number of protons is equal to 13, the number of electrons is equal to less than 13. Now we're going to look at that number. We have a +3 charge. That means that there are specifically 3 more positive charges than negative charges. Or we can translate to that too. There are specifically 3 more protons than there are electrons. Therefore, we can say that if there are 13 protons, that means there are 3 more protons than electrons. So that would mean that there would have to be 10 electrons. And again, I did not change that proton number because if I change the proton number, then I change the whole element. And we are given aluminum here, we are not given a different element. So I hope that helps clear up some confusion. And always feel free to reach out if you have any questions.